Ever wonder what actually happens the moment you type in your bank password and hit enter? How those secret characters travel from your keyboard, across the world, and into your bank's servers without someone snatching them along the way? The internet operates like a massive, highly organized global postal service. Just like regular mail, your data isn't sent as one giant box. Whether it's a photo or a password, it gets chopped up into tiny packages called packets. By default, this system uses HTTP, acting like transparent postcards, where everything inside is entirely visible. This means any delivery driver, sorting machine, or random person who intercepts that postcard along its delivery route can easily read exactly what you wrote. We can actually see this vulnerability on paper. This is a lab document detailing a real network capture. Look closely at Step 2. When a user logs into a website using standard HTTP, their username and password show up completely exposed in plain text. Because we cannot trust every stop along the delivery route, we have to look closely at the different layers of this digital mailroom to figure out how to protect our information from thieves. The first stop in our mailroom is the application layer. You can think of this as the original sender, the person actually sitting down to write out the message in the first place. Next, the message moves down to the transport layer. These are the mailroom workers. They take that long message, slice it into those tiny packets we talked about, and stamp a bold number on each piece so the receiving bank can put them back together in the right order. In the digital world, this is called a SYN flood. SYN is the signal used to synchronize. It is the handshake that starts a conversation. Hackers program computers to spam the mailroom with millions of these fake hello signals. The workers try to organize them all, get completely overwhelmed, and stop processing real mail. This attack breaks the system's ability to function entirely, shutting down the website for everyone by clogging the works with fake requests. Assuming the mailroom is running smoothly, those chopped-up packets still need exact coordinates before they can leave the building. This happens at the network layer. Here, workers stamp the packets with an IP address. You can think of an IP address as a precise set of GPS coordinates for the destination server. Humans don't memorize numerical coordinates. We memorize names, like a bank's website. To link the two, the internet uses DNS. As you can see, DNS is a global internet phone book, translating a familiar website name into numerical IP coordinates. In an attack called DNS poisoning, an attacker sneaks a fake numerical coordinate into that phone book next to your bank's name. When you try to send your password, the postal workers look up the bank's name, find the fake coordinates, and unwittingly route your secret packages directly to the hacker's warehouse. If the address book is compromised, even the most reliable delivery system will drop your data right into a trap. Finally, the packets reach the physical layer. These are the physical cables running under oceans and the Wi-Fi signals carrying your mail across the world. The danger here is incredibly direct. Hackers can physically tap into those cables or pull your Wi-Fi signals right out of the air at a local coffee shop. So if every single layer of this postal service has a weakness, how do we ever send anything private? The answer is a protocol called HTTPS. Instead of sending that transparent postcard out into the open, HTTPS places your message inside a heavy steel briefcase and snaps a cryptographic padlock shut. This process encrypts the data, scrambling the letters into complex math, hiding the contents entirely while moving through the mailroom. HTTPS doesn't stop the delivery truck from being intercepted, but it does guarantee that if a thief grabs your briefcase, they get absolutely nothing of value inside. Let's step out of the mailroom metaphor and look at what this actually means on a computer screen. If an attacker is watching live data flow across a network, they are going to capture those packets. Look at the lab instructions when the data is protected by HTTPS encryption. As Step 3 explains, the application data is no longer readable to the interceptor. Instead of a clear username and password, the attacker just sees scrambled gibberish, the digital briefcase held up against the interception. True cybersecurity is about securing every single stop on the delivery route. So the next time you log into your bank and see that little padlock icon in your browser, you'll know your digital armored truck is locked, loaded, and ready for transport.